Okay, so I've had some complaints that people couldn't see what I was writing on the board. So we're going to go back to the old-fashioned way with Mr. Hand. Hi! Um, and so we were working on 14. 14. We got 42.3 grams. We had 40 milliliters. We divided it out. We came out with 1.0575 grams per milliliter. That is our density. Any density that is greater than 1 and 1.0575 is greater than 1 is going to sink in water. Now, you have to specify, because if this was something else that had a different density than water, then it might float. But in water, which has a density of 1 gram per milliliter, anything less than that is going to float. Is going to float. Anything greater than that is going to sink. And so whatever our regular shaped object is going to sink. All right. 15. A density column is a container that has different samples of liquids. The liquids do not mix together. List the substances below in the order in which they would appear. So at the top is going to be the least dense. So it's going to be gas. Gasoline. And then in the middle, we're going to have water. And at the bottom, we're going to have dichlorobenzene. And that's the order they would be in. Gasoline, water, dichlorobenzene. The least dense is going to be at the top. The middle is going to be in the middle. And the most dense is going to be on the bottom. Hopefully everybody has that by now. All right. Lithium has 2 isotopes, Li6 and Li7. In abundances of 7.5% and 92.5%. Which isotope has the greatest effect on average atomic mass? Now, we could calculate average atomic mass. That would involve taking the mass number, which is 6, and multiplying it times the converted percentage and getting an answer, and the other mass number times the converted percentage. But I didn't read this very well when we were kind of going over this in class, and then adding the 2 answers and getting something like 6.9 something. But I didn't read the question in class. I was acting just like a student and only reading part. Which isotope has the greatest effect? Well, I don't even need to calculate anything. The most abundant thing is going to have the greatest effect on average atomic mass, as evidenced by 6.9 being much closer to 7 than 6. This is abundant at 92.5%, so Li7 is going to have the greatest effect on atomic mass. All right, 17. A group family is illustrated on the periodic table as a circle. 1 vertical column is what is this asking? Is illustrated on the periodic table as a circle 1. Oh, okay, circle 1 answer. Gotcha. A group family is a vertical column. Period energy level is a horizontal row. So groups, families go up and down. And periods and energy levels, or the number of shells, go side to side, right? A period is at the end of a sentence, and a group has up in it, in the name. Group, up and down, period, end of a sentence. Right? Right. Okay. Given the information, identify the family to which the following elements belong. Now, I'm going to give you a couple different ways to solve this. And I'm going to answer a question they're not asking, and that is, what is this? So there's 2 ways to answer this. The first way is to look at argon and see that argon has 18 electrons, and then see that I have 2 more, so that's 20 electrons. And see that the thing that has 20 electrons is calcium, right? The second way to solve this is to go to argon, or go to 4s. This is S block. I should get a marker. This is the S block here. This is the P block here, and this is the D block here, and this is the F block down here. Well, when it says 4s2 is the end of this, I can basically go to 4s1, s2, and guess what it is? It's that. So 4s1, 4s2, it is calcium. And calcium's family name, alkali earth metals. Okay. And I could do the same here, 2p5, 2, p1, p2, p3, p4, p5, p1, p2, p3, p4, p5, and say that this is fluorine. Or I can go, helium has 2 electrons. Helium has 2 electrons. 2 plus 2 is 4, plus 5 is 9. What has 9 electrons? Well, fluorine does. So I know that's fluorine. And I also know that that is the halogen family. 3s1. Again, 3s. 3s1 is sodium. Or I can go neon has 10 electrons, 11 electrons. The thing that has 11 electrons is sodium. And that is alkali metal. Okay. Wow, did they just give me the same thing twice? Really? Okay, so C and D are the same answer, unless I am crazy out of my mind. And I am not. They're both sodium. They're both alkali metals. And what is magnesium? Magnesium is right here. God, they are so unoriginal. Alkali earth metals. Instead of asking noble gases or... Yeah, so we have alkali metals, alkali earth metals, transition metals, boron group, carbon group, nitrogen group, boron group, carbon group, nitrogen group. This is sometimes known as chalogens or the oxygen group. This is halogens. This is noble gases. This is lanthanides and actinides. Okay, let's keep going. Label the following. Okay, name an element that would have a similar property as calcium. All right, well, I've already circled calcium. And the things that are going to react the same are going to have the same number of valence electrons. So they're going to have 2 valence electrons. So things in this row. So I could name any of these. I'm just going to name magnesium. Why? Because it has the same number of... Because it has the same number of electrons, and I'm going to use whatever shortcut I can, so number of electrons. Okay, label the following on the periodic table. Place an, okay, so S block, P block, D block, F block. Gases at room temperature, so that's going to be everything in the noble gases. It's going to be fluorine and chlorine and oxygen and nitrogen. So that's going to be everything that's a gas at room temperature. Circle liquids at room temperature. So we're going to have bromine and we're going to have mercury. Which, where are they placing mercury? 1, 2, 3, and mercury is going to be next to, yeah, it's going to be right here. So that's liquid. And really, cesium and francium, it can be argued either way that they're maybe not liquids. Everything else is solids. Metal, non-metal. So we have to make the stair step. So where is the stair step? The stair step goes like this. Just remember that it starts with this first little piece that extrudes, and then you just go like this, and go down and down and down and down. And what else does it say to do? Metals, label metals area, non-metals. Okay, so this is metals. And this is non-metals. Non-metals. And then, okay, so we've just discussed alkali metals, so I'm going to do this. Alkaline earth metals, I'm just going to draw arrows. Transition metals down here. Halogens are right here. Noble gases are right here. Oops. I don't know if that's too busy for y'all to see, but I feel like at this point, if you don't know that stuff, there's probably not a lot I can do to cement it in your head. But alkali metals, alkali earth metals, halogens, noble gases, transition metals, lanthanides, actinides. They don't ask very many questions about lanthanides and actinides. What is a periodic trend? It's a pattern of increasing or decreasing. And then property. So electronegativity is a property. A periodic trend is a pattern of increasing or decreasing. Define electronegativity. That is an atom's ability to gain an electron. I'm also going to put in parentheses its pull. It's how hard it's pulling on an electron. Which element is the most electronegative? Well, you have to know the pattern. So I'm going to draw some periodic table. I'm going to draw a little periodic table here. And I'm going to do this, and I'm going to do this, and I'm going to do this. And electronegativity, the pattern is like this, which means it increases going up and to the right, and decreases going down and to the left. So basically, the thing in this far right corner is going to be the most electronegative, not counting noble gases. So the thing that has the most electronegativity is going to be, not counting noble gases, is going to be up in this corner. It's going to be fluorine. As you go across the period from left to right, electronegativity increases. I drew the picture, and I know that it increases as I go left to right. Also as I go up. And as you go down a family, so as I go down, it decreases. Electronegativity values of noble gases are 0. 0, Z. Explain why. They have a full octet, which means 8 electrons. They have a full octet of 8 electrons. So they don't need another electron. So they're not going to pull to get another electron. All right. We can go a little bit longer. We can make this video just a little. This review is very long, so you just have to excuse me. But we got to cover everything, right? What does atomic radius measure? It measures from the. It actually measures. Well, from. Let's do it this way. The way they do it, it's 1/2 the distance between 2 nucleus. So you remember that picture where I have the nucleus, it's positively charged, and I have an electron cloud, and then I have an electron cloud. So I push these 2 atoms up against each other, and I can measure the distance because I can definitely define where the nucleus is. It's easy. I can shoot stuff at it and know where it is. So I measure the distance between these 2, and 1/2 of this distance is atomic radii. And now they're going to ask about the trend in atomic radius. And so again, I'm going to draw a little periodic table up here. And the trend is down and to the left. That means they get bigger as I go down, and they get bigger as I go to the left. So as I move across a period from left to right, atomic radius values decrease, because it's going the opposite direction. And as you go down a family, atomic radius increases, because we're adding shells, right? And the reason it decreases as we go across is because we're adding protons. Everything on this row has 4 shells. Everything from potassium all the way over has 4 shells. But bromine has 35 protons, whereas potassium only has 19. 35 protons are pulling those shells in tighter. When they pull them in tight and close, what do you get? You get a smaller atom. So as we go from left to right, we get a decrease in atomic radius. Okay, circle one element for each row. Which element in the group below has the highest first ionization energy? Ionization energy is how hard it is to pull an electron off of something. The trend is up and to the right for ionization energy. And for atomic radius, it's down and to the left. Hopefully you can see those two things. But okay, so what they've given me oxygen, sulfur, and tellurium. Since we're using these for all these answers, we're just going to circle them and go, okay. Highest first ionization energy is going to be whatever is at the top, right? If the trend is up and to the right, it's going to be oxygen. Largest radius is going to be at the bottom because that trend is down and to the left, so that's going to be tellurium. Lowest electronegativity is tellurium. Well, remember, electronegativity is the same as ionization energy. Electronegativity. So both of those trends go up and to the right. So whatever is going to be down below is going to have the lowest electronegativity and the lowest ionization energy. Highest electronegativity. Uh-oh, they've given me some new stuff to circle. So, NARBCU, NARBCU. I told you I would never make you make judgment calls like this, but I think these are far enough apart to where we can tell. N, F, and HE. N, F, and HE. All right. Highest electronegativity. Well, we already talked about noble gases have 0. The trend is up into this corner where fluorine is. So it's definitely going to be fluorine. Highest first ionization energy. That's the amount of energy to remove an electron, and noble gases are subject to that. You can remove an electron from a noble gas, so that's helium. Largest atomic radius. So that's going to be down and to the left, so that's going to be rubidium here. Okay, there were a lot of questions about this next one. And I told you that sometimes things break rank, right? So these two things are the same size. So it goes smaller, 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 bigger, smaller, smaller. So there's this, there's this little hiccup in the middle, but that doesn't affect how we look at other things. And generally we can see the trend here. 152, and then I go down by 40, and then I go down by, 30 something or 20 something, and then down by. So you can see what the jumps are. You know that they're going to get smaller. You know that we're going to start at 186, 160. Does it make sense to go to 98 and then get bigger all the way across? No, that cannot be my answer. Does it make sense to start at 44 and get bigger as I go across? No, I know things get smaller as I go from left to right. I can tell this. My trend is down and to the left for atomic radius. So it's between these two. Now this goes 72, 65, 62, 59, 50, 44. So basically what that is saying, if this is 44, that this is smaller than neon. Is that true? Or that that the second thing at 50 is smaller than, things don't get smaller as we go down, they get bigger. So the only answer that makes any sense is B, that this is 143, 118, 110, 103, 99, and 98. And let's see if it obeys the laws. Does it get smaller as I go from left to right? Yes, it does. Does it get bigger as I go from top to bottom? 31, 70, 98, 72, 99, 73, 103, 70, 110, 77, 118, 85, 143. There's only one answer there, people. Which subatomic particle identifies the atom? Well, a little hint. That number right there puts them all in order on the periodic table. It also tells me the number of what? Protons. Okay, now I told you not to use 24 electrons for aluminum. I told you to use 11 electrons for aluminum. So let's fill this out. Calcium 42, what is that? That means that this is an isotope, that there are 42. Oh man, this video is getting really long. Hang on, I'm going to stop it and put it in another video.